attempt to lecture on section 2.3. This is actually my second go at this. I gave a lecture on section 2.3 this morning, and it really kind of bit. And I only record my lectures every 3 or 4 years, and I didn't want that to be the lecture that you had to see for the next 4 years. So hopefully this is going to be better. So section 2.3 is all on circles, and it's all basically hinged on a single equation, which you may or may not be able to read on my video so well. But if you printed out section 2.3, then this is the little box that's right on the top of the page. And it gives a formula. And this formula, we say, is the formula that's going to help define a circle. Very specifically, we call this equation the standard form of the equation of a circle, or how about the standard form for the graph of a circle. And every single problem we do in section 2.3 is somehow going to be hinged on this formula. I'm going to lecture outside my handout for just a bit, show you how we might be able to use our calculator to graph a circle and talk about the formula, and then I'll get into the section. But this formula you're going to just have to have memorized, or we'll use it again and again. Probably by the time we get done with this section, you'll have this formula memorized. So I'm just going to do this. So this is not from my handout. This is just not from my handout. This is just to help you understand the formula. This is just to aid in understanding the formula. And very specifically, this formula says that if I can write an equation with numbers for h and k and r in this form, that I can produce a graph of that, and the graph is going to be a circle. And very specifically, the center of the circle is going to have coordinates h comma k, and the radius of the circle, that's the distance from the center to one of the sides, is going to be r. And real specifically, I'm going to write down a problem and graph it that is a circle. I'm going to just randomly make up numbers. I'm going to let h be 3. I'm going to let k be 2. And I'm going to let r be 5. So this formula, x minus 3 squared plus y minus 2 squared equals 5 squared, which I could have written as 25, is going to have a graph. The graph is going to be a circle. Which I'll show you in a second how to do it by hand, and then in a minute after that how to do it on your calculator. The center of the circle is going to be the point 3, 2. The x-coordinate of the center is the number after the minus sign, without the minus sign. The y-coordinate of the center is the number after the minus sign, without the minus sign in the y parentheses. And the radius of the circle is the number to the right of the equal sign that's squared. So you need to have an exponent of 2 in order to know the radius of the circle. So I'm going to draw this by hand now. So now I'm going to graph by hand and show you how much easier it is to graph by hand than it is with a calculator. Because by hand, I don't even need a table. I can just flat out graph this quickly. So I brought graph paper today because I knew I was going to do a lot of graphing. And very specifically, I'm going to graph a circle. I'm going to plot the point 3, 2, which is the center of the circle. So there's x equals 3, y equals 2. Here's the point 3, 2. And I say that the radius is 5. What it means for the radius to be 5 is that if I make a mark 5 units away from the center of the circle, I'm going to get to the edge of the circle. So I'm going to count 5 to the right of the center, make a dot. That's going to be a point on the edge of the circle. I'm also going to make a dot 3, 4, 5 to the left of the center of the circle. That's going to be another point on the edge of the circle. From the center now I'm going to go up 5 because the radius is 5. That point right there is also going to be on the edge of the circle. And I'm going to go down 5. So I'm going to get a reasonably accurate graph. Really I haven't plotted points. I plotted the center, and I knew the radius was 5. The radius is the distance from a center to the edge of the graph. And now I'm going to attempt to graph this. I bought this horrible compass today because I can't draw circles so well. And I'm going to attempt the best I can to use this compass to draw my circle. The compass is kind of widening on me. It's a really horribly cheap compass, but it's reasonable. And that's really as good as it's ever going to get for me. That would be a beautiful graph of the circle that's defined by the equation x minus 3 squared plus y minus 2 squared equals 5 squared. Notice I didn't have to make a table of values. I didn't have to plot any points. If an equation is written in this form where you have x minus some number squared in a parentheses, plus sign between, with a y minus some number squared in a parentheses equal to a number squared, you can generate a graph without using your calculator, without having to do a table of values, which is a beautiful thing. So let me just darken this so you can see it better, just in case it's not showing up on the video. You absolutely don't need to make a graph that's even as good as this. If your circles don't even look like circles and they look, you know, kind of round, I'll live with it. So that's how I would attack graphing that problem if I didn't want to use my calculator. I can use my calculator to generate a graph, and in order to use my calculator to generate a graph, which I wouldn't do because it's easy to do without my calculator, there's a lot of work to do. So if you insisted on using your calculator because you just like using your calculator, you know, how to graph a circle using my calculator, which this will probably be the only time I do this during this lecture. So how to graph using my calculator. My calculator, unfortunately, can't handle the equation written in this form. To graph, I need to have my equation solved for y. So I'm going to solve it for y. I'm going to first subtract x minus 3 squared from both sides in my efforts to solve it for y. When I subtract x minus 3 squared from the left side, I'm just left with the y minus 2 quantity squared. On the right side, I'm going to write this 5 squared as 25. I don't need to write it as 5 squared when I'm using my calculator. My calculator doesn't care how exactly that's written. So that's the first step in trying to get the y isolated, which is required for me to use my calculator to sketch a graph. Now I need to get rid of the square. To get rid of a square, you need the square root. And anytime I introduce a square root into a problem, I have to also introduce a plus or minus with one of the square roots. So I took the square root of both sides. The left side, because it's just one quantity squared, the square root will cancel out the square and leave me with just the y minus 2. On the right side, because this is not one quantity squared, this is 25 minus x minus 3 squared. It's not one whole. Not everything under the radical is captured in a parentheses with a square. It would be wrong to say this is 5 minus the quantity x minus 3. That radical, this radical doesn't reduce. If you reduce this to 5 minus parentheses x minus 3 by taking the square root of each piece, and you sketched a graph on your calculator, it won't match up with mine, so you can tell that you made some sort of mistake. I almost have this solved for y. I have it solved for y minus 2. To get it solved for y, I'm going to add 2 to both sides. The 2 I'm going to write to the left of the plus or minus sign. So I'm going to write y equals 2 plus or minus the square root of 25 minus x minus 3 quantity squared. That's what I need to graph. I can't graph I can't enter a plus or minus on my calculator. So when I go to do this graph, I'm going to type a y1 equation as 2 plus the square root of 25 minus x minus 3 squared. And I'm going to enter the y2 with the minus portion, with a 2 minus the square root of 25 minus the quantity x minus 3 squared. When I enter this y1 and y2 and do a graph, my calculator is going to produce a graph of a circle that has a center at the point 3,2. I won't be able to find the center on my calculator, and the graph will more or less look like this circle. It'll be smaller because my window is smaller, and a lot of times my calculator kind of distorts the graph and it almost doesn't look like a circle. It'll look more like a football or an ellipse. So I'm going to enter these two equations just to show you that if I didn't know the formula and I had technology, I could actually do the graph. So I'm going to hit my y equals button. I'm going to go 2 plus second square root of 25 minus x minus 3 squared. I need a double parentheses here in that radical. So under the radical, there's 2 left parentheses and 2 right parentheses. And for the next one, I'm going to go 2 minus second square root 25 minus the quantity x minus 3 squared. And again, for the y2, I also need, next to the radical, 2 left and 2 right parentheses. I don't know what function I graphed before this, so I'm going to hit my zoom button and then standard, and it's going to sketch a graph with a window that's going to be suitable for this particular circle. So I'm going to go zoom, go down to number 6 and hit standard. It's going to draw the circle in half. It drew the top half. Now it's going to draw the bottom half. Doesn't really connect the halves so nicely, but that's my calculator's representation of a circle with the center 3,2. If I look at go over 3 and up 2, that's about the dead center of the circle. It doesn't look so much like a circle. It looks more smushed. It looks more like an ellipse, and my calculator is just kind of flawed in that way. It doesn't do circles perfectly. But I didn't need my calculator to do a graph of the circle. As a matter of fact, to do the graph without my calculator, I just plotted the point 3,2, made marks 5 away from the center, drew a circle, no algebra whatsoever. With my calculator, there's a ton of algebra to do, and it's reasonably complex algebra that's, the kind of algebra you can make a mistake. So I'm not, unless I absolutely have to, I'm not going to take an equation that's written nicely for a circle and make it calculator friendly. So that's kind of the warm-up. So if I have an equation written in this nice form, x minus some number squared plus y minus some number squared equals some number squared, that function itself, that equation, will graph into a circle. I can pick off the center and I can pick off the radius of the circle. Now I'll get into the physical homework. The first 8 problems ask me to just write an equation of the circle and sketch a graph. They're really friendly problems. So I'm just going to remind you, because you might not have this memorized yet, that this equation, x minus h squared plus y minus k quantity squared equals r squared, is an equation that will graph for a circle. I want to create an equation of a circle that meets the criteria that's set forth in this instructions here. And I'm told very specifically that the h is 5, because it tells me that hk is 5 comma negative 4. So to come up with an equation for this particular problem, I'm going to replace the h in the formula with 5. I'm going to replace the k in the formula with negative 4. When I put a negative 4 in for the k, I have 2 negative signs next to each other. When I have 2 negative signs next to each other, I usually throw one of the negatives in a parentheses. And then to the right of the equal sign, I was told r was 4. I'm going to put 4 squared. That is the equation of the circle written in standard form. It's not simplified, and this wouldn't be the answer I would write if I was trying to write a nice answer for the equation of this circle. I'm going to simplify this a little bit. I'm not going to deal with the x minus 5 quantity squared. There's nothing nice I can do to it that's obvious. But the double negative in the y parentheses, I'm going to write that as y plus 4 quantity squared. And the 4 squared I'm going to write as 16. I would consider this the equation of the circle that has a radius of 4 that passes through the point 5, negative 4, written in standard form. Even though it's not technically standard form, because the standard form requires both parentheses to have a minus, and it requires it to have a square to the right of the equal sign, I can quickly transform this to the perfect standard form if I wanted to. But standard form isn't always reduced, and I'd like to reduce this a little bit. So that's half of problem 2. Now I'm going to sketch a graph. To sketch a graph, I don't even need the equation. I'm going to plot the center, 5, negative 4, and then go 4 up, 4 down, 4 left, and 4 right from the center for the radius and draw my circle. So half of the problem was to come up with my equation. That's taking the values of h, k, and r and plugging them into the formula. Now I'm going to plot the center, which is the point 5, negative 4. So there's my center. Because I was told that the center was the point 5, negative 4. Now I'm told the radius is 4. So from the center, I'm going to go 4 to the right, 4 to the left, 4 up, 4 down. I'm going to draw my circle. You don't need to use a compass, but since I have one and I can kind of use it, I'm going to attempt to use this compass to make a reasonable picture. It's not even going to be that good of a picture, but it is what it is. You'll notice this is a really horrible compass, and because of its horrible and my horrible abilities, what I'm getting is just nasty, but it is what it is. Hopefully some of you that are watching this are getting a good laugh out of this. So that's kind of the circle. Now I'm going to fudge and make it better. So the circle should go through each of the points that I marked. So that's reasonable. That's definitely probably a second grader could do better, but that's way better than I could do without a compass. Maybe the next one I'll try to do without a compass, because I don't expect you to buy a compass. So that would be the graph. So I've done everything for problem 2. I've written the equation in standard form, simplified it a little bit, and sketched a graph. And that's all that I need for the first 8 problems in this section. You don't need graph paper to sketch a graph. You can do a perfectly adequate graph without graph paper. So for the first thing I want to do is come up with my equation in standard form. And I'm going to do standard form plus simplify. I tell you that the r is 5, that the h is negative 6, and that the k is 3. I'm going to take those values and plug them into the formula x minus h squared plus y minus k squared equals r squared. So into the x parentheses, I'm going to put a negative 6 in for the h. Because I have a double negative, usually I make that second negative stick out in a parentheses. And then in the y parentheses, it's going to be y minus 3 quantity squared. To the right of the equal sign, I'm going to write 5 squared. That's technically the equation written in standard form that's asked for. I'm just going to write it a little bit cleaner. The double negative in the parentheses, I'm going to change to a positive and write that as x plus 6 quantity squared. And the 5 squared to the right of the equal sign, I'm going to rewrite as 25. So this would be, I would call this the equation of the circle written in standard form. And that's one of the 2 things that was asked for. I don't need the equation to graph. I just need to know the center and the radius to graph. So now I'm going to try to sketch a graph. I'll try not to use my compass, and you'll see how much worse it gets. Even though my compass didn't produce a great graph because of my limited abilities, it's going to get worse. So now I'm just going to sketch a graph. I'm going to plot the center at the point negative 6, 3. I'm going to go up 5, down 5, left 5, right 5, and try to draw a circle the best I can to finish up problem 4. So the center is the point negative 6, 3. Easy enough for me to graph that. The radius is 5, so I go 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5 down. Can't really get 5 to the left. I'm going to go 1, 2, 3, and I'm just going to call that 5, even though it's probably not exactly 5. It's probably more like 4.5. And then the best I can, I'm going to connect each of these points with a nice rounded side. And this is that's my circle without a compass. It's hardly any worse. It's starting to look less circular than not. But for me, you don't need to be any more accurate than that. If that's your drawing, if it's somewhere around that I can see the center and that it has nice points on the edge, that shows me that the radius is right, that's all you need to do. All right. 6 has a sneaky radius of 1/3, and I'm just going to make for a really small circle. Same sort of deal here. I'm just going to plug h in for 1 into the formula, k for 3 into the formula, r for 1/3 into the formula, and again that formula is x minus h quantity squared plus y minus k quantity squared equals r squared. The standard form for this particular circle is going to be x minus 1 quantity squared plus y minus 3 quantity squared equals 1/3, and I'm putting it in a parentheses because the fraction to square it, should be in a parentheses. The only thing I'm going to do to clean this up is square the 1/3. Squaring 1/3 is 1/3 times 1/3, and that's going to be 1/9, because when you square or multiply a fraction by itself, you multiply the numerators and the denominators together. The numerators are 1 times 1, which is 1. The denominators are 3 times 3, which is 9. So the equation written in standard form, and simplified, is going to be x minus 1 quantity squared plus y minus 3 quantity squared equals 1/9. So that'll be a really small graph, and I'm going to, again, I don't need the equation to sketch the graph. The information I need to graph it is I'm going to plot the center, and then I'm going to go left, right, up, and down 1/3 and draw a circle. So to finish up problem 6, I plot the center at the point 1, 3, and then I go up, down, left, and right 1/3. 1/3 is just barely over, because if I went all the way over to here, that would be 1 over, and I want to go 1/3. So I'm going to be really close to it. So it's just a little to the right, just a little to the left, just a little above, and just a little below. And I'm going to draw, the best I can, that circle. So that would be a circle with a radius of 1/3. So it's a really small circle because 1/3 is a small radius. And that's all I can do for problem 6. 8's going to be similar. 8's a big radius, which is to make it hard to fit on my graph. And the bigger the circle, the worse my graph. But the standard form I'm going to get by plugging in the values that are given. I'm going to let h be 0, k be 3, and r be 8. And again, I'll keep writing this formula down. Hopefully you have it memorized by now. So I'm going to go x minus 0 squared plus y minus 3 squared equals 8 squared. I'm going to clean up the standard form a little bit. X minus 0 squared, x minus 0 is the same as x. So I'm just going to write that as x squared. So you can have a letter without a parentheses and still be considered standard form, because x squared is the same as x minus 0 squared. So I don't absolutely have to see a parentheses with a minus sign for this still to be a circle. And so this is half of what I want. That's the equation written in standard form. Now I'm going to sketch a graph. I don't need the equation to sketch a graph. I need the pertinent information that the center is 0, 3, and the radius is 8. So I'm going to plot the point 0, 3, go up 8, down 8, left 8, and right 8, and then somehow try to get something that looks like a circle. And it likely is not going to look like a circle, but I'll deal with it. So the center of this is 0, 3. So I plot the point 0, 3. Go up, down, left, and right 8. So 1, 2, 3, 4, 5, 6, 7, right 8. 1, 2, 3, 4, 5, 6, 7, left 8. 1, 2, 3, 4, 5, 6, 7. Down 8. 1, 2, 3, 4, 5, 6, 7, and up 8. And then somehow I attempt to draw something that resembles vaguely a circle. And this probably is not going to vaguely represent a circle, but it's going to be the best I'm going to do right now. Apparently, it's been a long time since I've been in elementary school, and I don't really know how to use a compass. And this is what it is. So that's reasonable. You can't see that, so I'll darken it in. Notice I'm not labeling any points but the center. If you want to label some points, those points that I made dots on, that's nice, but you don't absolutely have to. This is all I'm looking for in terms of your graph. And again, it's still, even with a compass, it's not perfectly a circle, but it's pretty darn decent by my standards. All right, I think there's one more of these style of problems. No, there isn't. So now we're going to move into the next style of problem. So all the problems between 1 and 8 ask me to do the same sort of activity. The next problems between 9 and 18, these are the problems that are going to require some algebra that you may have forgotten, specifically factoring and completing the square. For each of these problems, they would graph to be a circle. By looking at the way the equation is written, I couldn't tell that it's really that it is a circle, nor could I tell that it would what the radius or center would be. A clue to know that this is a circle: there's an x squared and a y squared. There aren't numbers in front of the x and the y squared, and both the x and the y squareds are positive. Generally, when that's the case, when you have both an x squared and a y squared, with no numbers in front of the x squared and the y squared and a plus sign between them, if there aren't higher exponents around, you expect that to graph as a circle. In order to be able to graph this without my calculator, I'm going to rewrite the problem. I'm going to do this. I'm going to group the x's. I'm going to group the y's to get started. So I'm going to rewrite the left side with an x squared and a minus 2x. Grouped together, the y squared and the plus 4y grouped together. So that's what I mean by grouping the x's and grouping the y's, writing the x's next to each other and the y's next to each other. And the next thing I'm going to do is move over the constant. The number that doesn't have a letter can't be on the left-hand side. So I'm just going to take this and move it over. Adding 4 to both sides will have the effect of moving it over. So I'm going to get x squared minus 2x, and then plus y squared plus 4y equals to 4. So I haven't really done any technical algebra yet. Next to the x squared minus 2x, I'm going to put a plus sign. Next to the y squared plus 4y, I'm going to put a plus sign. I'm going to put numbers after those plus signs. Next to the 4 on the right-hand side, I'm going to put 2 plus signs. And next to the plus signs to the right of the 4, I'm going to write the numbers that I write next to the plus signs on the left-hand side. So after the plus sign, I need to write a number so that if I looked at just that portion of the left-hand side, that it factors nicely into a perfect square. The number I'm going to put after this plus sign is half of that negative 2 squared. The number I'm going to put to the right of this plus sign is going to be half of that 4 squared. So I'm setting the left side up so that I could get 2 parentheses with squares. And to get that set up, I need to figure out how to make that happen. I make that happen by adding a number after the x's and after the y's, not the same number to each. For the x's, half of negative 2 is negative 1. Negative 1 squared is negative 1 times negative 1, which is positive 1. I'm going to add that x after the x. After the y's, half of 4 is 2. 2 squared is 4. So after the y's, I'm going to add a 4. To the right-hand side, to keep the equation balanced, I'm going to add a 1 and a 4 because those are the numbers I added on the left-hand side. Now I'm going to factor. I'm going to factor these and these. Very specifically, we start off factoring x squared minus 2x plus 1. I have a template that I have memorized. I know that the signs have to be minus and minus. The last have to multiply to 1 and add to negative 2. And 1 times 1 is 1, and negative 1 plus negative 1 is negative 2. So the x squared minus 2x minus 1 factors into x minus 1 times x minus 1, which I'm going to rewrite as x minus 1 quantity squared. That's a good thing because that's the kind of writing I need to have a shot at getting the center of my circle. I'm going to bring down this plus sign, and I'm going to factor this y squared plus 4y plus 4. So now I'm going to factor that. There's no number in front of the y's, so there's no number in front of the y squared, so my first need to be a couple of y's. My last need to multiply to that 4 and add to that 4. That's going to be 2 and 2. So the y squared plus 4y plus 4 factors into y plus 2 times y plus 2. And I'm going to rewrite that as y plus 2 quantity squared. To the right of the equal sign, I'm going to go 4 plus 1 plus 4 is 9. For my purposes, this is the equation written in standard form. It's the nice simplified version of this. So this would be an acceptable, when I say write the equation in standard form, I don't really need to see the minuses or the r squared. But I'll show you how to get it if you need it. So I could say that this x minus 1 quantity squared plus y plus 2 quantity squared equals 9 is the equation written in standard form. Standard form does have a minus in each parenthesis, and it does have a square to the right of the equal sign. If you wanted to, you can take the y parentheses and introduce a double negative, because a double negative is going to be the same as a positive. So instead of writing y plus 2 squared, you can write y minus negative 2 squared. Now it's going to be in standard form on the left-hand side because I have the minus in the parentheses. Similarly, to the right of the equal sign, standard form has a square there, and I know that 9 is 3 squared. So if it bothers you that standard form says you need to have a minus in the parentheses and a square to the right of the equal sign, you can transform this into that, and this is probably more nice, well, it's nicer for graphing. So now I've got the equation written in standard form. Either this or this are both acceptable. And now I'm going to sketch a graph. When I sketch a graph, I just need to know the center and the radius. The center is going to be the point 1 and negative 2. Because if I write it in standard form, the number after the minus is the x-coordinate of the center. The number after the minus in the y parentheses is the y-coordinate of the center. And the radius is going to be this 3, because of the radius is the thing that's squared. So I'm just going to draw a circle that has a center of 1, negative 2, and a radius of 3. And I'll be completely done with this problem. So to finish up my graph, I don't need the equation to graph, I just need the bits of information from the equation that makes it graphable. The first bit of information is the center. The radius being 3 says once I find the center, I can go right 3, up 3, left 3, and down 3, and I can draw a circle. Don't absolutely need a compass, but it might be safer for me to use a compass. Or not. So that's a graph that's reasonable. It has the right center, and it goes through enough points so I can see that the radius is the 3 that it should be. So all the problems between 9 and 18 are going to have this flavor, where I'm going to have to group the x's and group the y's, add a number to make the x's factor, add a number to make the y's factor, and then I'll be home free. So 12 is going to be the same sort of problem. I'm asked to write the equation in standard form so I can sketch a graph. I'm going to start off and group the x's and group the y's. So I'm going to write this as x squared plus 2x, leave myself some room, plus y squared plus 6y, leave myself some room, and equal to 6. On the last problem, grouping wasn't enough. I had to do an extra step after I grouped because I had that 4 I had to get over to the right-hand side. In this particular problem, the number that doesn't have the letter is already on the right-hand side, so that second step that I did, I don't have to do again. So now I'm going to figure out what to add to each side. I'm going to put 1 plus sign next to the 2x, 1 plus sign next to the 6y, and 2 plus signs after the 6. And what do I add? By the x, I add 1/2 of 2 squared. Half of 2 is 1. 1 squared is 1. So next to the 2x, I'm going to put a 1. The thing that I add next to the 6y is I'm going to take half of 6 squared. Half of 6 is 3. 3 squared is 9. That 1 and that 9 that I added to the left side, I have to also add to the right side. Now I'm ready to go into factoring mode. I'm going to factor this. And I'm going to factor this. If you pick the right number to add, then you're going to get identical factors. If you didn't pick the right number to add, your factors won't be identical and you'll have to start over. So the first thing I'm factoring is the x squared plus 2x plus 1. This is nice to factor because there's not a number in front of the x squared, so my first are a couple of x's. There's no minuses there, so my signs have to be pluses. The last have to multiply to 1 and add to 2. And 1 and 1 will do that. So the x squared plus 2x plus 1 factors into x plus 1 times x plus 1, which I'm going to write as x plus 1 quantity squared. The y squared plus 6y plus 9, when I go to factor it, I get 2 parentheses. The first are a couple of y's. Didn't need a number in front of the y's because the y squared doesn't have a number in front of it. My last need to multiply to 9 and add to 6, and 3 will do that because 3 times 3 is 9 and 3 plus 3 is 6. So the y squared plus 6y plus 9 can be factored into y plus 3 quantity squared. To the right of the equal sign, 6 plus 1 plus 9 is 16. This for me is enough. This is written, this is the equation. Although it's not perfectly standard form, it's a simplified standard form. And that's what I'd be really looking for. If you need to see minuses in the parentheses, and you can put them in, you could rewrite the x plus 1 squared as x minus negative 1 squared because this double negative simplifies to a positive. Similarly, for the y plus 3 squared, you could write that parentheses as y minus 3 squared because the double negative simplifies to a positive. And for the 16, if you need to, you can write that as 4 squared. So this is more standard form than that is. This is kind of a simplified standard form. This is a unsimplified standard form. They're both correct. This is probably the more common way to write the equation. And now I'm going to sketch a graph, but before I sketch a graph, I need to know the center and the radius. The center is going to be the numbers after the x's, if you have the minus signs in there, and after the y's. So the center for this particular problem is going to be -1, -3. The radius is the number that's being squared, which is 4. So on my graph paper, I'm going to plot the point -1, -3. I'm going to go up 4, down 4, left 4, and right 4, and call that my circle, and then draw my circle and be done with problem 12. So when I do this problem, finishing up problem 12, for what that's worth, I probably should have written that up there. I plot the point -1, -3, which is my center. It's really the only point that I should label. I could label more if I want to, but I'm going to go up 4, down 4, left 4, and right 4, and I don't usually label those points. It wouldn't be wrong to label it, but it's not necessary. For that matter, if you're really good at drawing circles, you might not even have to do this up, down, left, and right. But I'm so horrible at drawing, having kind of 4 corners to shoot for makes my circle graphs a little bit better than if I don't give myself those targets. So that's, again, that's a circle, and this is the line back here that I really want. And that, again, that's good enough. Your drawings don't need to be any better than that, just as long as I can see the center and tell that the radius is more or less correct. 14, I'm going to do the same thing that I did for the last two problems, meaning group the x's and group the y's on my first step. That's already done for me. So the grouping the x's and grouping the y's is already done. And having the number set by itself on the right-hand side is also done. This problem, maybe it's so easy that it's hard. If you're trying to do this by yourself, that x might be perplexing. This x is okay. I don't need to do anything with the x in terms of adding something to it. If I wanted to, I can rewrite the x squared as x minus 0 squared if I needed to see the standard form with the minus. But because there aren't two x's, there isn't anything I have to do to the x squared piece of this, other than if I wanted to write it as x minus 0 quantity squared. I do have to doctor up the y's, and to figure out what to add there, I'm going to take half of negative 4 quantity squared. Half of negative 4 is negative 2. Negative 2 squared is positive 4. So what I'm going to add after the y's is a 4. And I also have to add that to the right-hand side. I'm going to leave the x squared alone. I'm going to factor this. Bring down that plus sign. Make my two parentheses. The firsts in the parentheses are a couple of y's. The signs are a couple of minuses. My last need to multiply to 4 and add to negative 4, and that's going to be negative 2 and negative 2, because negative 2 times negative 2 is 4, and negative 2 plus negative 2 is negative 4. To the right of the equal sign, 21 plus 4 is 25. So I could call this my standard form. I can say this is x squared plus y minus 2 quantity squared equals to 25. That would be considered correctly writing the equation in standard form. If I wanted to and I needed the minus signs and the parentheses, I could write x minus 0 squared plus y minus 2 squared equals 5 squared. So that's the algebra part. The graphing part, I don't need the equation except to get the center. In this case, the center is going to be the point 0, 0, 2, positive 2. And the radius is going to be 5. The radius is always a positive number. So I'm going to plot the point 0, 2 and go up 5, down 5, left 5, and right 5, and draw something that's more or less resembles a circle. And you don't need to do this on graph paper. I just printed this out for free from the internet, so I didn't buy any graph paper. So plot the point 0, 2, maybe label it just to be nice, and go 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 down. Draw something that more or less resembles a circle that actually goes through those points. And that would be a perfect graph for 14, although it doesn't really even look like a circle, but I believe that that's a circle. You could use a compass. I'm sure most of you can draw better than I can, which is a good thing. 16 is the last problem in this grouping, and no, maybe there's another one. There's an 18. 18 is like one of these things that's not like the other. 18 won't make its way onto the review or the test, but I just wanted to show it to you. So in this problem, the x's are already grouped. There's only one y, so I don't need to worry about adding something after the y. I could, if I want to, that y squared part, write that as y minus 0 squared. But the only part where I need to add is after the x's. The number to add after the x's is going to be half of negative 4 squared. Half of negative 4 is negative 2. Negative 2 squared is negative 2 times negative 2, which is positive 4. I'm going to add 4 to both sides. I'm going to factor the x squared minus 4x plus 4. When I do that, that factors into x minus 2 times x minus 2. I'm going to write that as x minus 2 quantity squared. And this, for me, would be the equation of this circle in standard form. If you didn't like that, you could write the 9 as 3 squared. and the y as y minus 0 squared. When I go to sketch my graph, I just need to know the center. In this case, the center is going to be 2, 0. I need to know the radius, which is going to be 3. So I'm going to dig out my graph paper. I'm going to plot the point 2, 0, go up, down, left, and right 3, and make something that more or less resembles a circle. So 2, 0 is my center. Go 1, 2, 3 to the left. 1, 2, well, 3 is actually 3 to the right. 3 to the left. 1, 2, 3 up. 1, 2, 3 down, all from the center. And then draw something that has some roundness to it. That would be, again, hardly a circle, but good enough. And that's the graph for 16. You don't need to use this compass. Apparently, I was really struggling with this compass, so I decided not to use it. 18 is, like I said, 18 is something nice for you to watch. There's some subtleties in 18 that make it harder and not something I'm going to put on a test. First of all, there's numbers in front of both the x and the y squared. If those numbers were different numbers, if it was like a 2x squared and a 4y squared, the graph would be an ellipse. If there was a minus sign between the x squared and the y squared, the graph would be a hyperbola. So if you did those in high school, hyperbolas and ellipses we don't get to graph in this class, but when numbers are in front of the x and the y squared and they're different, then you don't get circles. To do problem 18, I can't have a number in front of the x squared and the y squared. I need to divide those numbers away. So I'm going to divide everything by 2 to make the problems more like the problems we've been doing. So I'm going to get x squared plus y squared plus 4x plus 3 equals 0. Now I'm going to group the x's, make it x squared plus 4x plus y squared plus 3 equals to 0. There isn't a y to group. I'm going to minus 3 from both sides to get the number without the letter over on the right-hand side. This gives me x squared plus 4x plus y squared equals negative 3. The y squared I don't need to do anything to. If I had to, if it bothered me, I could write it as y minus 0 squared. After the x squared plus 4x, I need to add a number. The number I add is half of 4 squared. Half of 4 is 2, and 2 squared is 4. I'm going to add 4 to both sides. I'm going to factor this. This factors into x plus 2 times x plus 2, which I can write as x plus 2 quantity squared. And on the right-hand side, I get 1, because negative 3 plus 4 is 1. This would be considered perfectly written in standard form. If you needed to, you can rewrite it as x plus 2 quantity squared plus y squared, and I need the right side to have an exponent, and 1 squared is 1. And I should probably write that as y minus 0 squared. So for this particular parabola, the center is the point 2 comma 0, and the radius is 1. The radius doesn't have to come out to be an integer. I was kind and made all the radii come out to integers, but it didn't have to. And getting radiuses that aren't integers gets kind of messy, and I didn't want to get into that. So I'm going to plot the point. Oh, I messed up here, and nobody's here to watch me do this. If I wanted to rewrite this better, this should be x minus negative 2 squared. So there's a certain danger to me working the problems by myself with nobody supervising me, and this would have been a mistake because the plus sign isn't right for standard form. To write it with the minus sign, I need a double negative to give me that plus back. The center should be negative 2, 0, and the radius should be 1. Now I'll graph that. Put a center at negative 2, 0. Go right 1, up 1, left 1, down 1, and draw a circle the best I can. And that center is at the point negative 2, 0. All right, so we're 2/3 of the way done through the section. The last group of problems, I don't know if they're the hardest or not. They're just different. And the last group of problems, I give you information about a circle, but not enough to come up with an equation. And I want you to come up with an equation and sketch a graph. And my hint is to actually sketch the graph first, because sketching the graph is going to help you unlock the key to figure out what the unknown is. So to get an equation for a circle, which is my goal for problem 20, I need an h, a k, and an r. I gave you the center, so the h in this problem is going to be 1. The k in this problem is going to be 5 because the center has the h and the k for the formula. But I don't know what the r is, and this is where this problem gets a little bit tricky. I have to somehow figure out how to get the r from the information that's given, and I'm going to graph this circle crudely, but good enough. The information in this problem says the circle has a center at the point 1, 5. And in addition to that, it passes through the point 5, negative 3. So that this circle, this line right here, is going to be a radius. And if I started to draw this circle, it's not going to fit on my graph, I don't think. So that's the beginnings of drawing. I'm going to try to draw a little bit more of this circle. So this is the circle that is described in the problem. The radius is the distance from the center to the edge, and in order to get the radius, I need to use the distance formula. So this distance right here is the radius. I need to remember the distance formula. The distance between 2 points, which we did in a previous section, you get by doing this. You do x2 minus the square root of x2 minus x1 squared plus y2 minus y1 squared. So in order to get the radius, which is the distance between the center and a point on the edge, I'm going to use the distance formula. And I'm going to call, it doesn't matter what I call x1 and x2. I'm going to call the center the first point. So I'm going to call x1, 1 and y1, 5. And this point on the edge, I'm going to call x2, 5, and y2, negative 3. I'm going to take those 4 values and plug them into the formula. So the radius, which is the distance between those 2 points, is going to be the square root of x2, 5, minus x1, 1 quantity squared, plus y2, which is negative 3, minus y1, which is 5, squared. So the radius, which is the distance between those 2 points, so maybe I'll just write r because it's the length of the radius, is going to be the square root of 4 squared, and this next parenthesis comes out to negative 8 squared. So the radius is going to be the square root of 16 plus 64, because 4 squared is 16, 8 squared is 64. The radius is going to be the square root of 80. The formula doesn't require the radius. The formula requires the radius squared. So if I know what the radius is, I can get the radius squared real easy by squaring the radius. I find out what the radius squared is. So if the radius is the square root of 80, I square the radius and get r squared. And if I square a square root, the squaring cancels out the square root symbol, and the radius squared is going to be 80. The number that's going to go into my formula is going to be 80 to the right of the equal sign, because to the right of the equal sign, I need the radius squared. So very specifically, into my formula, I'm going to plug in 1 for h, 5 for k, and 80 for r squared, because I need the r squared in the formula and not the r. And r squared is nicer than r anyway. So to get the answer, the equation for this circle is going to be x minus 1 quantity squared plus y minus 5 quantity squared equals 80. This is the equation of the circle written in standard form. Problem 22 should have the exact same feel, and then I think the problems get a little bit trickier. But none of them are going to be horrible, hopefully. Yeah. So 22 gives me the center again, which is nice. If I give you a center, I tell you what the h is, and I tell you what the k is. This tangent to the y-axis will mean something to you when you take calculus. It may not mean anything to you now. Tangent to the y-axis means the graph touches the y-axis but doesn't cross the y-axis. So I'm going to draw a picture to help me figure out the unknown, because I need to know the radius to get my equation. So I'm going to graph the information that's provided. I'd say that the center is 4, 1, and I say the graph is tangent to the y-axis, which means there's the y-axis is one of the edges of it's on the edge of the graph. So I'm going to draw this circle in the best I can. It's not going to be that much of a best, but beautiful, wasn't that? So that's the picture that's being described. The circle is tangent to the y-axis, which means the y-axis, there's a point on the edge that is the point on the circumference of the circle that is on the y-axis, and I have to be able to tell what that point is. Real specifically, that point right there is going to be exactly horizontal from the center. That's going to be the point 0, 1. Same sort of deal here. I need to get the radius. The radius, actually, I need the radius squared. The radius is the distance between the center and a point on the circle. I'm going to do the same thing. I really don't need the distance formula, but I'm going to use the distance formula. I'm going to call the center x1, 4, y1, 1. Took the center for the first point. My point that I constructed, 0, 1, I'm going to call x2, 0, and y2, 1, and I'm going to use the distance formula. The radius is going to be found by taking the square root of x2 minus x1 squared plus y2 minus y1 squared. And so if I do that, I get the radius equals the square root. x2 is 0, x1 is 4, so I get 0 minus 4 squared, plus y2 is 1 minus y1 is 1. So I get the radius, the length of the radius is 0 minus the quantity 0 minus 4 squared, plus the quantity of 1 minus 1 squared. So I'm going to get negative 4 squared for the first parentheses, 0 squared for the second parentheses. Negative 4 squared is 16. 0 squared is 0. So I get the radius is the square root of 16. The square root of 16 is 4, but in the formula I need radius squared. So the radius squared is going to equal to the radius squared, which is 4 squared, which is going to be 16. So when I go to find my formula, the number that I'm going to put to the right of the equal sign, which is the radius squared, is going to be 16. So I did all this work. I drew my circle. My circle gave me the ability to know how to find the radius, because I'm using the distance formula. It gave me the point needed to find my distance. So in this particular, I'm going to say r squared is 16. And again, the formula for the circle is x minus h quantity squared plus y minus k quantity squared equals r squared. The answer to this problem is going to be gotten by putting a 4 in for the h, a 1 in for the k, and a 16 for the r squared. So this is the equation, or the answer to problem 16. This is all that's asked for. I don't technically need to sketch a graph to do problem 22, but if I didn't sketch a graph, I might have not been able to figure out what the radius was. 24 is actually harder than 26, but I'll do it first just to get it done. So 24 gives me information. It doesn't give me the center, which is really unfortunate. It just gives me, it says it has a diameter. The diameter is a line that goes through the center across the circle of 1, 5 and 3, 11 as its endpoint. So let me plot those points. 1, 5 311, it says that this right here is the diameter. And so that if I try to draw this circle that's defined by this, it says there's a circle that goes through. So the picture that's being described here is more or less that picture. This is a circle, more or less, that has those points, 1, 5, and 311 as a diameter. I'm supposed to know that the center of a circle is in the midpoint of the diameter. So this right here is going to be the center of the circle. It looks to me like it's the point 2, 8. I could gamble and say the center is the point 2, 8, or I can use the midpoint formula because the center is the midpoint of this diameter. I'm going to do that. So I'm going to find the center, which is the midpoint of the diameter. And of course, you haven't forgot that the x-coordinate of the midpoint is x1 plus x2 over 2, and the y-coordinate of the midpoint is y1 plus y2 over 2. To get the midpoints, you add up the x-coordinate of the point and divide by 2. You add the y-coordinates of the points and divide by 2. So the x-coordinate of the midpoint, I'm going to add the x-coordinate of the points, 1 and 3, and divide by 2. This is going to give me 4 over 2, which is 2. To get the y-coordinate of the center, which is the midpoint of this line, I'm going to add the y-coordinates of the points, which are 5 plus 11, and divide by 2. This is going to be 16 over 2, which is 8. So the center of the circle that's described is the point 28. I also need to know the radius. So I can be happy with that, but not be done. To get the radius, I need to know the distance between the center and one of the points on the side. I can find this distance right here, or that distance. I'm going to find this distance right here. So the radius is going to be the distance between the point 311 and the point 28, or the distance between 28 and 15. They're equal. And to do this, I'm going to need an x1 and a y1. I'm going to call the center 28, x1 and y1. I'm going to need an x2 and a y2. I'm going to call that the point 311, but you could have picked the other point. I'm going to plug the numbers into the formula. The radius is going to be the square root of x2 minus x1 squared, which is 3 minus 2 squared, plus y2 minus y1 squared, which is 11 minus 8 squared. So the radius is going to be the square root of 1 squared plus 3 squared. So the radius is going to be the square root of 1 plus 9. The radius is going to be the square root of 10. The formula needs the radius squared. So the radius squared is going to be the square root of 10 squared. Squaring a square root, you just drop the square root symbol. Radius squared is going to be 10, because this operation here, this squaring cancels out that square root. So into my formula, I'm going to put 10 in for the radius squared. I'm going to plug 2 in for the h and 8 in for the k. And I'm done with my algebra. So in this problem, the h is the x-coordinate of the center, which is 2. The k is the y-coordinate of the center, which is 8. The radius squared is 10. I'm going to take those numbers and plug them into the formula. X minus h squared plus y minus k squared equals r squared. My answer to the equation for this problem is going to be x minus 2 quantity squared plus y minus 8 quantity squared equals r squared, which is 10. It's the harder of the last two even problems. Now I'll do 26, which is the same style of problem. It's just, for some reason, it's a little bit easier because the endpoints are, well, they're just friendlier. I can probably do this without as much fuss, but I'll do the same amount of fuss. So the question is worded similarly. It says, I don't give you the center nor the radius. I give you the endpoints of the diameter. So this particular graph is a circle that has one edge of a diameter at 5,4 and another edge at 5,0. And let me graph this again for you just so you can kind of see what this graph is supposed to look like. If I can actually do that. This can't be the way you're supposed to work a compass, but it's the way I'm working the compass. It's getting worse. All right, so this just really is failing me. So this is more or less what is described, and my circle doesn't go through the endpoints, but this right here is the diameter that's described. The center is the midpoint of the diameter, so this right here is going to be the center. It looks to me like it's the point 5, 2, but I'm going to find that for certain. So if the x-coordinate of the center is the midpoint of that line segment. And to find the x-coordinate of the center, I'm going to add up the x-coordinates of the 2 points and divide by 2. So I have a 5 plus a 5 over 2, which is 10 over 2, which is 5. To get the y-coordinate of the center, I'm going to add up the y-coordinates of the points and divide by 2. That's going to be 0 plus 4 over 2, which is 4 over 2, which is 2. So the center for this circle is the point 5,2. The radius is the distance between the center and one of the points on the side. So this is going to be my radius. I'm going to use the distance formula to find this. The radius is going to be the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. I'm going to use the center for the x1 and y1. So x1 is 5. y1 is 2. I'm going to use the point 5,4 for my x2, y2, but I could have used the other point. I'm going to say x2 is 5, y2 is 4. Plug those numbers into the formula. I'll get the radius is the square root of x2 minus x1 squared, which is 5 minus 5 squared, plus y2 minus y1 squared, which is 4 minus 2 quantity squared. So I get the radius is 0 squared plus 2 squared. So that's going to be the radius is 0, the square root of 0 plus 4. So the radius is the square root of 4, which is 2. I want to know what the radius squared is. The radius squared is going to be 2 squared, which is going to be 4. So when I go to write the equation, I know that the center is 5,2. That's my HK. And to the right of the equal sign, I need an r squared, which is 4. So I'm going to take those 3 bits of information, specifically that the center is 5,2. So the h in the formula is 5. The k in the formula is 2. And the r squared is 4. Again, for the last time, the formula is x minus h quantity squared plus y minus k quantity squared equals r squared. I'm going to plug the bits of information that I've got computed and get my answer. So the equation of a circle that has diameter with endpoints 5, 0, and 5, 4 is x minus 5 quantity squared plus y minus 2 quantity squared equal to 4. So that's everything in this section. Hopefully that'll get you through. Hopefully there aren't any evil tricks in the odd problems that I haven't discovered because I haven't written the key for the odd problems yet.